Okay, let's dive right into this. Welcome, everyone, to today's explainer. If you're an 8th grade student tuning in, or honestly just someone who is curious about the incredible invisible forces that are literally shaping our universe every single day, you are in the exact right place. Today, we aren't just going to look at boring formulas in some dusty textbook. No, we're actually unlocking the secrets of the world around us. We're going to explore the chemical foundations of our everyday lives by looking at two massive, incredibly important groups of chemicals: acids and bases. Get ready, because what we cover today is going to completely change the way you look at your kitchen, your bathroom, and yep, even your own body. Here's a quick roadmap of what we'll be covering today. First, examine your world. Second, defining acids and bases. Third, why chemistry matters. Fourth, everyday science examples. And fifth, education and morality. Section 1. Examine your world, a call to understand. So I want to start by framing exactly why we study science in the first place. Our source material anchors this whole idea with a principle from Scripture, specifically 1 Thessalonians 5:21, which says, "Test everything, hold fast what is good." The text uses this to emphasize a really profound point. As students of life, testing the substances we interact with every single day isn't just busy work, it's a call to truly understand our environment. We examine these things, we figure out exactly how they work, and we learn how to use them safely. We hold fast to the knowledge that helps us make good, smart choices. Moving on to Section 2, defining acids and bases, the two chemical families. In the vast world of chemistry, acids and bases are two incredibly important families, and they have very distinct, almost completely opposite personalities. So the crucial starting point is understanding what exactly makes an acid, well, an acid. By definition, an acid is a substance that produces hydrogen ions, which scientists write as an H with a little plus sign, when it's dissolved in water. You can really think of these hydrogen ions as the fundamental chemical signature of an acid. Whenever you have an acid interacting with water, it's releasing these tiny, positively charged particles. And that single atomic behavior, that's exactly what gives acids all of their famous characteristics. On the flip side, we have bases. A base is defined as a substance that produces hydroxide ions, written as OH with a little minus sign, when dissolved in water. Notice the huge contrast here. While the acids are busy releasing positive hydrogen ions, bases are out there producing negative hydroxide ions. This is the fundamental chemical difference between the two families. It's basically a chemical yin and yang that dictates how these substances behave, how they react, and what they ultimately do. Now, what's really interesting about this is how vividly these two chemical families oppose one another. Acids produce H plus ions, right? They taste very sour. Think of a fresh lemon. They're highly reactive with metals, and if you test them with a special indicator called blue litmus paper, the acid will immediately turn that paper red. Bases, however, produce OH minus ions. They taste bitter, and physically they actually feel slippery to the touch. And if you use red litmus paper on a base, it miraculously turns blue. Now, just a quick, absolutely crucial safety note for all my young scientists out there. In a real chemistry lab, we literally never identify chemicals by tasting or touching them. But in nature, these are the properties that define them. Section 3, why chemistry matters beyond the laboratory. You know, it's super easy to hear about H plus and OH minus ions and just think, okay, sure, but what does this actually have to do with me? Well, this abstract science is dictating almost everything that happens in your daily life. First off, your very own stomach is basically a bubbling chemistry lab right now. It relies on strong acid to break down the food you eat so you can absorb nutrients. Then look at baking. Have you ever baked a cake and watched it get huge and fluffy in the oven? That happens because baking soda, which is a base, is reacting inside the batter. Furthermore, the soaps, shampoos, and heavy-duty cleaners in your house, they rely entirely on these chemical properties to lift dirt and kill germs. On an even larger scale, scientists are constantly adjusting acidity and basicity to manufacture the medicines that keep us healthy and to generate the energy that powers our world. Chemistry isn't just stuck in a lab, it's inside you and it's all around you. Section 4. Everyday science examples. Chemistry in action. Let's actually pull these concepts completely out of the textbook and put them right into your hands. Example number 1, lemon juice. Whenever you bite into a slice of lemon and get that sharp, sour pucker that makes your eyes water, you are directly experiencing an acid. Specifically, you're tasting citric acid. That intense sourness is the tangible, real-world proof of those hydrogen ions we talked about earlier. Example number 2, soap. When you're washing your hands after dinner or taking a shower, notice how the soap feels incredibly slippery between your fingers. That slick, slippery sensation is the physical hallmark of interacting with a base. And it's that basic property that allows the soap to latch onto tough grease and oils on your skin and wash them right down the drain. And this brilliantly illustrates what happens when our two chemical families actually meet. If you've ever built a model volcano for a science fair, you know exactly how this reaction goes. Step 1, you take vinegar, which is an acid, and mix it with baking soda, which is a base. Step 2, you watch in amazement as they rapidly react, bubbling and fizzing violently to create a completely new substance, carbon dioxide gas. This is neutralization in action. The acid and the base are reacting, they're trading ions, and they are chemically transforming right before your eyes. So our source material leaves us with a bit of a challenge. A fun homework assignment for today's explainer. I want you to act as active scientists in your own homes. 1, define an acid in your own words. 2, define a base in your own words. 3, list at least one property of each. And now for the fun part. 4, go hunt through your kitchen and find one example of an acid. And 5, find one example of a base. Go test your new knowledge against the real world. Section 5, Education and Morality, the heroesmartacademy philosophy. So this is where the explainer takes an interesting pivot. We transition from making safe choices in a chemistry lab to the broader philosophy guiding our source material. The core philosophy stated in the HeroesmartAcademy Godly Learner series is this: education without morality will hurt. The curriculum argues that, well, we've just learned how powerful chemicals like acids and bases are, right? And in the hands of a responsible scientist, that knowledge can create life-saving medicines. But the text proposes that knowledge without a strong moral compass can actually be dangerous. The point they're making is that knowing how the world works is really only half the equation. Knowing how to act rightly and ethically with that knowledge is what truly matters. The source material connects this idea directly to a scriptural promise found in Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. The curriculum draws the lesson here that true peace and true wisdom don't just come from memorizing the periodic table or understanding ions. It suggests that true peace comes from aligning our educated, scientific minds with spiritual wisdom and moral integrity. And that brings us to a really powerful, lingering question posed by the text. What's the point of being smart and supposedly educated if you continue to make bad choices that hurt yourself or others? As you go forward testing the world, mixing chemicals, and learning how the universe operates, it's a profound reminder from our source material to really consider how you use that knowledge. Thanks for joining me on this explainer. Stay curious, and we'll see you next time.